Hi everybody, today March 18 we will continue solving exercise 1, part 4 and 5. In part 4 the question is to find the derivative of f of x, f prime of x, and then to set up the table of variation of f. Question 5 is to write the equation of the tangent t to c at a point of abscissa 0. So we'll start by 4. First, we will find the derivative f prime of x. So f of x is in the form of u over v. So the derivative is u prime v minus v prime u over v squared. U is the expression in the numerator and v is the expression of the denominator. So u prime is the derivative of the numerator expression, which is equals to 2x plus 4. V is x plus 6 minus v prime is the derivative of x plus 6, which is equals to 1. U is the numerator expression. Now the second step is to expand and reduce the numerator expression. So after expanding and reducing the numerator expression, which is easy, so 2x squared plus 12x plus 4x minus 24 and minus the expression of u, we will get the expanded and reduced expression of the numerator, x squared plus 12x plus 27. But the question is to show that f prime of x is in this form, that is the factorized form. So it remains to factorize the expression in the numerator, which is a polynomial of second degree. So the factorized form of any polynomial of second degree, the general formula is equals to a, which is the number multiplied by x squared, x minus x1 into x minus x2. x1 and x2 are the roots of this polynomial. We can use the help of the calculator to find the roots x1 and x2 by pressing mode 5-2. So we will have, in our case, x1 is equals to minus 3, x2 is equals to minus 9. So replacing x1 by minus 3, x2 by minus 9, a by 1, then the factorized expression of the second order polynomial is equals to x plus 3 into x plus 9, and thus we will get the desired result, which is f prime of x in this form. Now the second part in this question is to set up the table of variation of f. So the first step to set up the table of variation of f is to find where at what values of x f prime of x vanishes, that is at what values of x f prime of x is equals to 0. So f prime of x equals to 0 in general when the expression numerator expression is equals to 0. So in our case, the numerator expression is the factorized form, which is x plus 3, x plus 9. So x plus 3 into x plus 9 is equals to 0 when at x equals minus 3 and x equals minus 9. So after finding the values where f prime of x is equals to 0, then we are able to set up the table of variation of f. So first step is to draw a table, f prime of x, f of x. First step is to plug the domain of definition, which is minus infinity, minus 6, plus infinity. Different, at minus 6 we don't need minus 6 because of the domain of definition. And then we plug minus 9, minus 3. As I said, these are the values of x where f prime of x is equals to 0. So f prime of x is 0 at minus 9, 0 at minus 3. So at the left and right of -9 and -3, f prime of x is positive. Just take a value here, 0, let's say, plug 0 in the expression of f prime of x, you will get a positive number, then the sign is positive. Similarly, take -10, for example, plug -10 in the numerator, just in the numerator expression of f prime of x, you will get a positive number, so the sign is positive. Similarly, also here, between -9 and -6, take for example -7, plug -7 in the expression of f prime of x, in the numerator expression. It is sufficient to just plug the number in the numerator expression. So you will get a negative number, and then the sign is negative. Here, -6, -3, take, let's say, -4. Plug -4 in the numerator expression of f prime of x, and you will get a negative number. So the sign of f prime of x in this interval between -6 and -3, when x is between -6 and -3, is negative. Then f prime of x, when f prime of x is positive, f of x in this interval between -infinity, -9 is increasing. Increasing from what values? So in the last video, we find the limit when x tends to -infinity, and the answer was -infinity. So f of x is increasing from -infinity, and then in this interval between -9 and -6, f of x is decreasing because f prime of x is negative. Similarly here, so when f of x is increasing and then decreasing is in the second interval, you will a maximum is formed. So here we have maximum. Here f of x is decreasing and then increasing, then you will have a minimum. The maximum here is f of -9, and here the minimum is f of -3. Also, the limit when x tends to -infinity of f of x is equals to -infinity. We find this limit in part 2. So just replace, put here -infinity, and also we proved that when x tends to -infinity, we will have an oblique asymptote, y equals x minus 2. So we just replace this information on the table of variation. Here we have when x tends to -6 the answer was, the limit was -infinity. When x tends to -6 the answer was +infinity. So we replace this information on the table of variation, and we have x -6 as a result is a vertical asymptote. Similarly, when x tends to +infinity, the answer was +infinity, and we have also y equals x minus 2 is an oblique asymptote. So this is a table of variation with all the information proved in the above questions. So now, question number 5, we need to write the equation of the tangent t to c at a point of abscissa 0. So first of all, the equation of the tangent t is y minus ya. The general equation is y minus ya equals f prime xla into x minus xa. So xa is given. xa is equals to 0. Why? Because in the question they said write the equation of the tangent t to c at a point A of abscissa 0. So xa is equals to 0. The unknowns here are xa, f prime xa, ya. We need to find, first step, we need to find these, the values of these terms. So xa is given always. xa is equals to 0. Ya is equals to f of xa, that is f of 0. So replace x by 0 in the expression of f of x. We will get minus 3 over 6, which is minus half. So ya is minus half. Now f prime of xa is equals to 0. F prime of xa is equals to f prime of 0. So replace 0 by x by 0 in the expression of f prime of x, and you will get 3 over 4. Now just plug these terms, ya, f prime xa by their values. So the equation of the tangent is now equals to y plus half equals 3 over 4 x plus 0. 0 is xa, 3 over 4 f prime xa, half is ya. Now take the plus half to the right hand side. It will become minus half, and expand this term 3 over 4x plus 0. So this is the final form of the equation of the tangent, which is an equation of a straight line. Remark here that f prime of xa is the slope of this tangent, always. F prime of xa is the slope of this tangent. This tangent is a straight line. So before ending this lecture, as a homework, please, if you can solve this exercise number 2. And in the second video, in the next video, I will solve this exercise, but please try to do this exercise as much as you can. And then in the next video, we will do the solution together. So thank you, and see you in the next